Good morning students. 11th standard chemistry unit 2 quantum mechanical model of an atom. In today's session I am going to teach you about the quantum numbers. What are quantum numbers? Quantum numbers explains about the energy and position of an electron. Quantum number explains about the energy and position of an electron. Okay. The definition for quantum number is given here. Electron in an atom characterized by arbitrary number, those numbers are called quantum numbers. Electron in an atom characterized by arbitrary number, those numbers are called quantum numbers. So, the quantum numbers is divided into 4 types. So, there are 4 main types of quantum numbers are here. One is principal quantum number, second one is azimuthal quantum number. It can also be named as angular momentum quantum number, and the third one is magnetic quantum number, and the fourth one is spin quantum number. These are all the 4 types of quantum number. So, let us discuss the types of quantum numbers one by one. So, the first quantum number is principal quantum number. This principal quantum number is denoted by the letter n, small n. Okay. So, this principal quantum number describes the energy level of an atom. This principal quantum number describes the energy level of an atom. So, this n has some values. What are all the values for n? I have written here the values of n is equal to 1, 2, 3 and 4. Okay, these are all the values of principal quantum number. By using these values, I can able to identify the place of the electron. Where the electrons is revolving around the nucleus, I can able to find out by using the principal quantum number values. So, if n is equal to 1, the electrons will be present or the electrons revolving around the nucleus in the K shell. Okay. In the same way we can see for n is equal to 2 and n is equal to 3, then n is equal to 4. If n is equal to 2, where the electrons will be present? The electrons will be present in the L shell or the electrons revolving around the nucleus in the L shell. If n is equal to 3, n value is 3 means the electrons will be present in the M shell or the electrons is revolving around the nucleus in the M shell. If n is equal to 4, the electrons will be present in the nth shell. So, let me write the values of n and the shell here. So, if n is equal to 1 means the subshell will be K. If n is equal to 2 means the subshell will be L. If L is equal to 3 means what is the subshell? If L is equal to 3 means the subshell will be M. If n is equal to 4 means the subshell will be N. Okay. This you have to remember in any time. Okay. By using these values, I can identify the position of electron in main shell. Okay. So, let us calculate the maximum number of electrons by using this formula. Okay. By using this formula, we can calculate the maximum number of electrons which is present in the nucleus. So, let us discuss one by one. For K shell, I am going to calculate the maximum number of electrons. What is the formula is given here? The formula to calculate the maximum number of electron is 2n square. So, this is K shell. What is the n value for K shell? N value will be 1. N which is nothing but the principal quantum number. So, in the place of n, I am going to substitute the value of 1. So, 2 into 1 square. So, 1 square will be 1. So, 1 into 2 I will get the value 2. So, in the K shell only the maximum electrons present is 2. In the same way we can see for other subshell too. Okay. Then we can go for the L shell. What is the formula is given here? 2n square. It is L shell. So, L means what is the value of n here? The value of n is 2. So, I am going to substitute in the place of n, I am going to substitute 2. So, let me write here 2 into 2 square. 2 square will be 4. 4 into 2 I will get 8. So, in the L shell the maximum number of electrons will be 8. Then we can go for the M shell. The formula to find out the maximum number of electron is 2n square. So, since it is a M shell, the n value will be 3. So, I am going to substitute like this, 2 into 3 square. 3 square will be 9. 9 multiplied by 2, I will get 18. So, in the M shell, I can have the 18 electrons. Then the last one, what is the formula to find out the maximum number of electrons? 2n square. So, since it is a n shell, what is the value of n here? The value of n is 4. So, 2 into 4 square. So, 4 square will be 16. 16 multiplied by 2, that is called, we can get 32. So, we have find out the maximum number of in each subshell. Okay. The K shell means I can have the 2 maximum number of electrons. In L subshell I can have 8 electrons. In M subshell I can have 18 electrons. In N subshell I can have 32 electrons. In this way we can find out the maximum number of electrons by using the formula 2n square. Okay. So, in addition to this, I can find out the energy of the electron in main subshell. The formula is given here, En is equal to minus 1312.8 Z square divided by n square kilojoule per mole, or this can be written as kilojoule mole inverse. Always the energy of the electron should be negative. We should remember this, always the energy of the electron should be negative. Hope it is clear to everyone. So, thank you.